time. Well, Kieran is going to present us more about the ingredients for building a successful driverless team. So we're excited to hear about your history, about the MIT Delft team, and to learn more how to build up such a successful team.
And also address a little bit the specific challenges in the US. I think this is also what you will touch on.
Cool. Awesome. Thanks a lot, guys. Well, let's get into it.
All right. If you're ready to go, please go ahead.
Awesome. So thanks a lot for the introduction, guys. I just wanted to start out by really quickly saying thank you so much to FSG and Waymo for putting this event on. I think it's like really important that we try to drive this to become a reality in the US. So I really appreciate you guys putting in the effort on this. So anyways, today I'll talk quick about some of the ingredients that we see that we've seen have been super useful in building a successful North American-based driverless team. And there's kind of three things that I'll touch on today. So first off, what are some of the specific challenges, like was mentioned before, specific challenges that you'll face while trying to bring up a team in the US? Secondly, some of the really big differences between bringing up a electric vehicle team or a combustion vehicle team to bringing up a driverless team. And then the third thing is really trying to pass on some of the lessons that we learned from going through this process. And hopefully you guys can take those lessons and make sure that you don't make the same mistakes that we made along the way. So anyways, just to start us out here, if the slide switches, there we go. Just to start us out here, I kind of wanted to start by just introducing myself a little bit. It's useful to kind of know who's yapping at you here. And also, this really helps, this will help motivate why I'm super interested in this competition. So I know we're mostly engineers here. So what I thought I'd do is try to boil myself down into a visual plot here. Of course, as engineers, we like plots. I've boiled myself down into 3 dimensions. So first off, the bottom dimension, the x-axis is time. Then the first red axis here is Kieran's practical mechanical engineering knowledge. So I've kind of I've got this into 3 different levels. So marginally understand F equals MA. Can answer beam bending questions and then know how to use Space Mouse for CAD. And then the third dimension to myself that I think is relevant for this is my practical software engineering knowledge. And so, again, got different levels here, knowing that Python is not a snake, going up to, being some sort of proficient with using terminal, and then, super advanced features in VIN, such as avoiding using the arrow keys. And so just to start out with kind of my mechanical engineering knowledge trajectory through time here, I started at the University of Waterloo back in 2012, where I started my mechanical engineering bachelor's degree. You can see each of these little blips on the graph here are an exam period where, you learn a bunch of stuff, you cram everything in over a week, and then you forget it all and are usually dumber afterwards. And then after I graduated, I went to MIT, and that's where I went to grad school. And this kind of weird meandering trajectory is me in grad school, where I don't fully know what happened. One of the things I did realize while I was in grad school, though, is that if you were to plot my software engineering practical knowledge, it was essentially flatlined. And that really concerned me when I realized that, software engineering is going to be really important going forward into the future for engineering. And so I really wanted to change that. And that's when, just fortunately, this little birdie called MIT Team Delft started coming up, and was really conceived right at the same point in time that I was starting to make this realization. And just to go back to my motivation on this is the opportunities that were given to me by the team were incredibly valuable in helping me change this flatline trajectory. And I really hope that other universities in North America can do the same thing, not only just mechanical engineers, but also software engineers as well, because I believe that there's definitely a gap in software engineering education for practical hands-on experience. So anyways, that's a little bit about me, a little bit about my motivation on this. So anyways, to get into who is MIT Team Delft, this is a picture of our 2019-2020 team. And we're a collaboration between TU Delft in the Netherlands and then, of course, MIT in the US. And what I'm going to do is just kind of plot essentially our timeline along the line on the bottom here. And the reason I really want to do this is because I want to show how much effort it took to bring up this team and how much time it spent and how many times we got kicked down in the process of it. So just to start out, it was around the end of 2017 when we really started getting the initial conversations going between Delft and MIT. Things moved fast after that. So, after we signed on the dotted line, we had our first wave of recruiting in March of 2018. Then we had our second wave of recruiting in September of 2018. And really, I like to call this period between these two recruiting phases as our period of darkness, because we had absolutely no clue what was going on. And what was really great about that is we learned a ton. We learned an absolute ton during this phase. Anyways, once we had that second wave of recruiting, we ended up in November of 2018. We closed about 150K in sponsorships. We used this money to really ramp up our development. We had our first integration trip to Delft in January of 2019. The car absolutely did not work during this trip. We had our second integration trip to Delft in April. Car still definitely did not work. And then we had our final and third integration trip to Delft in July. And the car kind of worked, maybe not really, but this was about a month before competition season started. Another thing I'd just like to highlight, it was around just after April, I think, that we realized that USB-free cameras were a really, really bad idea. This is not necessarily relevant to the timeline. I just want to make it sure no one makes the same mistake. But anyways, that kind of definitely helped us out in the 2019-2020 season development. And then finally, in July, when our car still didn't really work, in August of 2019, we finished second place in Italy, rather, and third place in Germany. And what I really want to show with this is essentially we went through a year and a half of development where things didn't work and we kept getting kicked down. And then suddenly in the last month of the 2018-2019 season, things really came together. So when you guys are going through your journey in building up a team like this, just remember that we spent a year and a half where nothing worked. So if you guys are in the same state where nothing is working for the first year and a half, don't worry, it'll all come together in the end. So anyways, that's just a little bit of background on MIT Team Delft. Next, getting into kind of the real meat of the presentation here, I just want to give a real quick disclaimer. The process, because of course we're going to be focusing on this presentation for the process of building a team. The process for building and operating an EV team or CV team, so electric vehicle or combustion vehicle team, is not the same as the process for building a driverless team. They are very, very different beasts. And one of the things that I want to say with this is that, they're not necessarily, that isn't to say that the skills and knowledge you gain from leading an electric vehicle team or combustion vehicle team, that is still very, very relevant to building up a driverless team, but they are not the same. And so you should not use the same playbook. If you're coming from an EV or CV background, you should absolutely not use the same playbook when building up your driverless team. There are a couple really important differences to highlight, and we'll kind of dig into a little bit more of these throughout the presentation. So first off, EV and CV, strongly mechanical engineering driven. Driverless vehicles, strongly software engineering driven. And this mechanical engineers and software engineers are just different beasts. And this really, the differences in this really reflect in how you approach your recruiting strategies. Secondly, EV and CV, those competitions are just simply more mature. I mean, I wouldn't necessarily go to the point where say they're fully mature, but they are more mature than the driverless competitions, given that there are no driverless competitions currently in the US. And this really affects how you approach your sponsorship strategies. And so we'll talk more about that in a second. And then thirdly, how you approach development for the two different competitions is absolutely different as well. So for electric vehicle, combustion vehicle teams, you have to follow a much more waterfall-based approach where you plan out your execution strategy and then you go do that. You then go execute. Whereas for driverless teams, you have to maintain a much more agile mindset as you're going through your development, and that'll strongly influence how you go about doing your development. And we'll talk about that with respect to testing in a bit. So, anyways, these are kind of some of the main differences. And so, we actually get into, now we actually get into the meat of the presentation. So I want to talk really quick about what are the ingredients for a successful driverless team. And with the theme of, showing plots to represent everything, I've kind of got a cartoon on the side here. So I've got team goodness on the y-axis and then time on the x-axis. And, team goodness can mean whatever you want it to mean. I've got it here as, once you reach a reasonable level of team goodness, you're at a point where you can win FSG. And what I'm going to do is I'm going to, for each of the ingredients I'm going to highlight, I want to correlate those to how those affect this team goodness versus time plot. And so we'll go through this in a second here. So first off, recruiting. You need to do proper recruiting, and you need to get the people right and build a community. And where that influences this team goodness plot is it really sets your initial conditions. That's essentially, that is the most important aspect of proper recruiting is to set your initial conditions right. And you need to build a community as you go forward. The second really important aspect is you need to get lots of money from sponsors. The people that you've brought on here, you need to give them money to do stuff. And where I see that fitting into kind of the boundary conditions of this team goodness plot is it really sets your initial derivative. It really tells you, it really shows you, it gives you something to step off of, essentially. It really is what enables your initial development is you get money to buy hardware and to, start, going on integration trips, et cetera. That's really where the sponsorship money comes into things. And then finally, which was talked about a lot in the last presentation, you need really good testing and software infrastructure. These people that you've hired on, you've just given them a bunch of money and you need to make their lives easier. And where testing and software infrastructure really comes into this plot is it's really what allows you to maintain this trajectory of team goodness upwards towards winning FSG. And so that's kind of the three main ingredients. So recruitment, sponsorships, and testing and infrastructure. And we'll dive into the details of each of these throughout the presentation. So first ingredient, first step, recruit. And just a fun fact with this, you will not be able to recruit enough people. I will, and even if you follow the steps that I'm going to highlight in this presentation, you will not be able to recruit enough people. What I can guarantee you, though, is that you will be able to recruit less, not enough people. And so you really need to put a lot of time into this, and you really need to get your recruitment strategy right. And just to start out, this isn't necessarily specific to driverless competitions or to US-based teams, but the time you spend recruiting will be your largest ROI. So return on investment on time. And I just want to highlight that with like a little line calculation here to kind of motivate what we're going to talk about next. So if you look at a typical project, somewhere on the order of around 20 engineers for a team, each engineer is spending about 25 hours a week on the project, and you'll work about 40 weeks in the year. Each of these numbers may be a little bit less, a little bit more for different teams, but these are rough estimates of how much time will be spent on a project like this. And so what this ends up resulting in is for each year you spend developing a vehicle or spend developing a stack, you will have to, as part of the leadership of the team, you'll have to manage 20,000 engineering hours. That is a lot of engineering hours. And so you need to make sure that the people who are spending those hours are the right people. And so you really need to spend a lot of time during recruitment. And so I just want to highlight what we did for our first initial recruitment round at MIT. We spent about 200 hours in the first 2 weeks focused on recruitment, and that seems like a lot. And even with 200 hours worth of time spent recruiting, that still gives you 100-to-1 leverage. And what I mean by 100-to-1 is for every hour you spent recruiting, that resulted in 100 engineering hours. And so that is huge. So you need to do your recruiting right. You need to spend a lot of time doing your homework before you start recruiting, and because it has huge leverage and a huge effect on your team going forward into the future. So before you actually even start recruiting, you really need to figure out what are you recruiting for? Like, what are the traits and the people that you're recruiting for? And this is maybe more specific to the US teams. I'll highlight 3 here that we found were really, really important. They're not all specific to the US teams, but maybe more important for the US-based teams. So first off, one of the things that we found was really, really valuable was having people that had project-based experience. So people that, were able to work with software on hardware, and have hands-on experience doing that. Were able to, use duct tape and sticks and twigs to just make sure their product worked. So these were some of the most successful people we had on our team as people who had project-based experience. Secondly, this one is probably the one that's most relevant for US-based teams, and I'll get to why in a second. But you want to find people who ask more questions than you ask them. So if you're in an interview with someone, if you're interviewing a candidate for a role on your team, and they spend more time asking you questions during the interview than you have time to ask them, you should hire them, 100%. And then the third thing is look for people who reject your rejection. So if you go through this process with someone, the interview process, and then you tell them that it's just not going to work out, and then they call you back and say, "Hey, I don't accept your rejection," you should hire them because those people are motivated. And so at a high level, the kind of three main, the three themes to these is, first off, you need people with hands-on experience, you need people who are excited about the project, and you need people who are motivated. So yeah, that kind of walks through that. But the one thing I do want to mention with this is I am not saying to recruit the people with the best coding background. Of course, you need some sort of baseline knowledge when it comes to writing code, but those are not necessarily the right people or not necessarily the best people for the project. And we'll dive into that in the next slide here. Another thing, so with these, if you're investing 200 hours into recruiting, maybe a lot of these 200 hours are spent getting your initial wave of recruiting done. But you also need to look at it from a long-term aspect as well, because you need to essentially build a pipeline of students into your team. And so for this, I would strongly recommend building external partnerships. And there's two external partnerships that I would recommend. So first off, find labs within your school that have credit-based programs, and this one is critical for US teams. I've got a picture on the side here of some of the labs that we've worked with and some of the advisors we've had on our journey developing the team. But the reason why this is so important for US-based teams is because the model that the US-based teams will be operating on is very different than the European model. The European model has a lot of opportunities for integrating your work with Formula Student Driverless into your master's thesis, or taking a full year off to dedicate yourself to the project. Whereas this is not the case for US-based teams, as there's a lot more, ties to individuals' funding, which results in you just not being able to invest as much time in the project. So it's really important to try to find labs which have, projects or other things for credit where students can take on personal projects, and then they can use that time to work with the team. Then the other external partnership I would recommend is look at local universities nearby your university. Don't just restrict yourself to just strictly your university. There's a lot more logistics involved with this, but we found it to be very beneficial, as in setting up kind of like pseudo internship programs with other schools for them to come work with your team, contribute, and learn from your team as well. So don't just restrict yourself to your own university. All right, so let's get into some of the actual things that you should do while recruiting. And I really want to stress the title of this slide is don't just take your AV, don't just take your autonomous vehicle to the open house. You have to do a lot more than that. Now, that doesn't mean don't take your vehicle to the AV open house or to the open house. That means don't just take your AV to the open house. And the reason for that, I'll dig into a little bit of the reason for that, is it's really tied into the fact that software engineers and computer science students are very different than mechanical engineers. So for mechanical engineering groups, where you can take your vehicle to an open house and it attracts a lot of other mechanical engineers, and you can come around and talk about the vehicle on static display. You can see how the other mechanical engineers design their parts or what sort of analysis they did, et cetera. You can touch and feel the hardware. Whereas for software engineers, this just doesn't work. And what we found was really, really useful for recruiting software engineers and computer science students in the US was having live demos. So you can see a picture on the slide here of myself and Crystal, one of the members of our business team, with a live demo of our testbed. And on the screen that's in the background there, We've got our LiDAR pipeline running on it and perception system running. And so computer science and software engineers can actually come and, play with the environment around the vehicle and see how it affects the algorithms that are actually running on the vehicle. So we found this to be really, really useful for recruitment in the US. Secondly, this really ties to the title of the slide. Don't just take your AV to the open house. You need to advertise a lot. You need to go past just the open house, whether that's through emails, class visits, posters. The picture here on the slide is me in a class visit. I think I did in the first 2 weeks of recruiting last year. I think I did 12 class visits over those 2 weeks. So you really need to work on your shameless plug, going to classes and trying to find people. And when you're doing this, you really need to make sure you have a clear, succinct message. There's lots of noise on campus, and you want to make sure that you can stand out from all that noise. So you really need to work on having a clear, succinct message on why people should join your team, rather than everything else that's going on around the university. Then the third thing I wanted to talk about is, even though this is point 3, I really think that during your recruitment, you should start by recruiting your business operations team. They are absolute magicians. They will help with steps 1 and 2 here, because they will be great at setting up these sorts of displays and organizing them. They'll be great at helping make sure that you get your message right. They are just, they have skills that you couldn't imagine. So I would strongly recommend that you start by recruiting your business operations team before you actually get into your technical team. Got a picture on the slide of Jorge and Dan, who were part of our business operations team last year. This is a picture of them. They showed up to a meeting in both independently in blue cardigans and white collared shirts. And so we called this the MBA uniform for the team. But anyways, start by recruiting your business operations team. And so lastly, on recruiting, I really want to drive home the point that for US-based teams, this is really important for US-based teams, you are not just the one doing the interviewing. Candidates will also be interviewing you too. Universities are full of opportunities. And so you need to make sure your team stands out from all the other opportunities that are on campus. And the one thing that we think is really important for doing this for US-based teams, US-based software teams, and I'll get to that in a second, is really building a community around your team. And there's a couple different ways you can do that. First off, you need to build an awesome workspace, because this will attract people and this will keep people around for the long term, because you really need to work on the retention rate of the people you hire on. Some people might think that this is only really relevant for mechanical engineering teams. I would say that this is even more relevant for software engineering teams. And the reason for that is because software engineering teams, software engineers have the luxury of working from home. And when you're in a situation where, the one big thing you have to keep people on your team is the community that you build on your team. When people are always working from home, you don't build that sense of community. And so this is really, really important that you have an awesome working space that people can come to and really call their second home. So the software engineers on your team can really get a lot of face time with each other. Second thing I would want to talk about real quick is give the team members a sense of identity. This is also really important for building a community on your team. I've got a picture on the slide here of myself and one of the other perception team members. We got team shirts, just for our specific sub team. And what that did is it really built a tightly knit group of engineers that wanted to work together and wanted to stick together, and that really helped with retention on the team, because that's a big problem. Retention is a big problem for US-based teams. So you need to put in a lot of time to make sure you can increase your retention as much as possible. And then the third thing I would want to highlight is you really want to do things with your team and do things often. Whether that's going for offsites or whether that's going for just getting everyone in the same room for meetings or things like that. You really want to try to do this as much as possible. And in saying this, I want to stress again that looking at this, maybe some people will think that all this stuff is really obvious. Like, of course we're going to do that. This stuff is so critical for software teams and so critical for US teams that you really need to put a dedicated effort into all of these. So I really hope that the teams that are coming up can put a special effort into these. So anyways, to do this stuff, you need to get a lot of money. And that's really step two for bringing up driverless teams in the US. The pro tip I would want to give on this is you should budget to fry at least two of everything, because you probably will, and we did. So whatever you think your budget is, multiply that by about 3, and you should be good. Before you even start actually collecting money, though, and what I'm going to talk through here is very, very specific to US teams, you need to figure out why your sponsors want to give you money. You need to figure out what kind of motivates your sponsors and what value you can provide to your sponsors as well. And so through our experience with this, I absolutely cannot say I'm an expert in this, but through our experience, through our empirical learning on this, we found that there's three main groups or three main benefits that you can provide to sponsors that they really see a lot of value in. And so the first one is recruitment. This one's really important in the US. You want to find, some sponsors are very, very interested in recruiting the talent that's on your team. And one of the big reasons for this is that the skills you learn in the Formula Student Driverless competition are directly transferable to industry. I've talked to a lot of the members, the kind of alumni on our team that have graduated and gone into positions within the AV industry. And they essentially say that the work they did with driverless is essentially the exact same as what they're doing in industry, just maybe scaled up 2 or 3 times. So the skills and lessons you learn working in the Formula Student Driverless competition is directly transferable to industry. And sponsors are really interested in this. Second thing I want to highlight is publicity. This one's actually really important for AV teams, so driverless teams, because there are a lot of sponsors right now, or a lot of companies right now that are very interested in getting some association with autonomous vehicle development. There are a lot of sponsors that might be older in age that are trying to come up with some of the new technological developments. And so you can provide a lot of value to these sponsors. And this was a big aspect of the sponsors that we took on last year. You can really help them, whether it's through ad space on your car or social media posts, etc. You can really help these sponsors gain the publicity and association that they might be interested in. And the third thing I'd want to talk about is, you might think that I'm just trying to sound warm and fuzzy inside or something with this, but there really are sponsors that are just simply interested in enabling students to learn and enabling students to progress. And the tip I give when you find sponsors like this is they are most interested in the students. They're most interested in the student's experience. And so you want to give these sponsors a personalized experience when showing off your team, and you really want to focus on the people rather than necessarily focus on the hardware that you're developing, et cetera. And so in summary on this, I want to say that when you're approaching a sponsor in the US, you want to figure out, what of these 3 or what combination of these 3 or maybe others is really important to these sponsors, and then give them a personalized, a tailored sponsorship to that. And then going next to after figuring out what a sponsor wants, you need to figure out what your strategy for sponsorship is. And what we used the strategy of going few and big rather than many and small. So then we had a few large sponsors rather than having a ton of small sponsors. And then this was definitely a difference between the European and US model for sponsorships. Kind of the best way to put it in this case is the less the merrier. Picture on the right here is actually a picture of us with Waymo. Waymo was a huge sponsor of our team over the last 2 years. And because we took this strategy of going few and big rather than many and small, we really got to tailor the sponsorship to what Waymo was interested in and provide mutual benefit between the two of us. And what that resulted in is it just simply resulted in a win-win situation for both groups. And because of it, a lot of our alumni are actually now in high impact positions within the Waymo team, actually. So it's been a win-win situation for everyone in this. And the other thing with this is you get to manage less. And there's a lot of US sponsors that are willing to give these larger sums of money, $20,000 plus to teams. And so when you're going through your recruit or your sponsorship strategy in the US, you should really try to focus on these big sponsors rather than small sponsors. The second thing I would want to talk about is don't restrict yourself to AVs. you should really go beyond. You should even go beyond automotive OEMs. This really goes back to the publicity point I made before. Is that there are a lot of people really interested in getting into or getting associated with the autonomous vehicle space or driverless vehicle space. And so, we had a lot of conversations with companies in the robotics industries, companies in logistics, heavy machinery, etc. So really don't restrict yourself to AVs only. Anyways, step 3. And so I probably won't spend too much time on this. I know that a lot of the other teams or a lot of the other speakers will go much more in depth into the value of testing and automation. But I really wanted to, even if someone else is doing a completely dedicated talk to this, I want to just really highlight how important this is. How important this is to bringing up a team and being successful at competition at the end of the year. So you need to test and automate, and you need to do it often. And so what we did in our second year actually is we hired on dedicated testing and software infrastructure leads. And I need to make a direct call out to these guys because these guys are huge for our team. So we've got Simon on the left here, who is our software infrastructure lead in Europe. We had David in the middle, who was our testing lead, and then Ravi on the right, who was our software infrastructure lead in the US. And I'll just read out the top of the slide here. These are the most underappreciated positions until you don't have them. So it's really important to hire on these people because they really enable your development team to do awesome things. So I strongly recommend you hire on dedicated testing and software infrastructure leads. And then on that, what I would recommend is start testing from day one. And this was really a theme in the previous presentation as well. One thing I definitely need to make very, very clear with this is that, especially in your first year, do not build a full vehicle from scratch. I should almost have a full presentation on just this. If you do this, your first test day will probably be at competition, which is not good. And with software development and trying to maintain an agile approach to things, you need to test as much as often as possible. I would not necessarily say you shouldn't consider building a full vehicle from scratch, but if you're going to do that, probably do it once your team is more mature and consider it as a 2-year project, because just the time limitations of the Formula Student Driverless competition makes it really difficult to do this as a 1-year project. Second thing is start testing from day one, and this was driven home in the last presentation as well. Your car will probably not move for the first 6 months, but don't give up. That does not mean you should not still try to test. And the reason for this is testing is a logistics nightmare. So full vehicle testing is a logistics nightmare. And so during this initial phase of testing, you should focus on learning how to test rather than actually collecting data. So learning what sort of tools you need, learning what sort of, figuring out where you should be, what sort of tracks or places you can test at, figuring out what the process is for getting the vehicle there, etc. This is really important. It takes a lot of time to do. And if you just start doing this, once you have a stack that's almost stable, you will never figure out your testing process and you'll never be able to test. So it's really important that you start testing as soon as possible and not get discouraged when your vehicle doesn't work. And then the last thing I want to point out on this is you should, in order to stay agile, especially during this 4 to 6 months where you aren't going to be able to test anything, I would strongly recommend that you build a test bed. We've got a picture of our test bed on the side here. This is RR1, which is the name of it. This really helps you stay agile, like I said. Vehicle testing, so full vehicle testing, is expensive and risky. Risky, I mean, as in there's a lot of work you have to do to make sure you get safety approvals and make sure you get a site to test that, et cetera, et cetera, et cetera. Whereas if you go with a scaled testing approach like you would with the test bed you see on the slide here, it's much cheaper and it's safer. As in, it's easy to take the vehicle out to a parking lot, and if you accidentally slam on the gas of this vehicle and it goes into a wall, the only thing that's going to be damaged is the car itself rather than any property. And it's much easier to get safety approvals, et cetera, to be able to test with it. So I strongly recommend that you build a test bed to stay agile. And then the last thing I want to talk about, I won't dive too much into this because I know some of the other teams will be talking a lot more about this in detail, but it's, again, just something I really want to highlight. You should start building your infrastructure from day one as well. And I see there to be 3 purposes of infrastructure. So first off, for bringing new people on board. So whether that's through easy machine setup or general onboarding, etc., or a good development environment setup, is really helps you bring new people on board. Secondly, it just helps your team develop. Whether that's through just a quick example of it is really good training infrastructure for whatever machine learning role that you're running. That really helps accelerate your development. And then third, and I think most importantly, is your software infrastructure or testing infrastructure really helps you gather and consume data, and you're going to have a lot of it. And I've got a picture highlighted on the slide here of a GUI developed by Simon that was specifically developed for testing and gathering data. And the one thing I want to highlight with this was a really, really professionally developed tool. You should not make your software infrastructure hacky. You should really put a lot of time into making sure it's done right, because it'll pay off 10x in the long run. To really invest a lot of time into it. And then just to wrap things up, I wanted to give one bonus ingredient. Again, you might think, Kieran, you're just trying to be warm and fuzzy, but I strongly actually believe in this one. You need to figure out what the guiding principle of your team is. And if you do this, it simplifies all the other steps that I've highlighted here. So if you ignore everything else and just figure out what your team's guiding principle is, it'll help everything else in your journey to FSG. And so for MIT Driverless, for example, MIT Driverless is the hub of applied autonomy at MIT and a proving ground for engineers to develop the skills they need to be successful in industry. And where this helped in all the previous steps is when we were going to recruiting events, we had a clear message that we could give recruits for why they should be joining the team, and they knew exactly what they would be getting into. When we were going to sponsorship events, we could give sponsors a clear understanding of what the purpose of our team was. And then, as we were testing, this really influenced our data-driven testing approach because we were focused on applied autonomy. And so if there's anything you get out of the presentation, just try to figure out what your guiding principle is for the team. With that, I just want to thank everyone for your time. I've left my email and contact information on the bottom here. If you want to discuss anything about the content of the presentation outside of this, please feel free to get in touch with me. I'd love to talk through.
Yeah, thank you so much, Kieran. So
yeah,
thanks
lovely.
for your great input.
Thank you so much.
Somehow kind of a scientific approach.
Yeah, definitely. It's really interesting.
A great input, and also we got some feedback and some questions from teams. And we have a few minutes left, so we shoot some questions. And then one is, it seems that an international partnership has many benefits. So who was taking the initiative and why? How could you start, and who should we contact?
So there are absolutely a lot of benefits from an international partnership. And actually, our partnership has kind of grown over the years. To be honest, the initial kind of concept of the partnership has really changed. The initial concept was that Delft would work more on the mechanical engineering aspect of the vehicle, and MIT would work on the autonomous stack. And once we kind of finished a lot of the hardware engineering side of the team, the Delft team could really start bringing up and actually managed a ton of the autonomous vehicle development in our second year. And so this kind of approach of combining forces with a mechanical engineering powerhouse and a strong computer science software engineering team group worked really well in the first year and enabled our success in the second year. And I wouldn't necessarily say this is strictly for international relationships. It just so happened that we had a lot of strong contacts at Delft when we were developing our team. But I just think finding that partnership between a mechanical engineering powerhouse and a really strong software engineering group will be super useful in the first year, and then exponentially more useful in the second year once the mechanical engineering powerhouse is probably better than you at software engineering. So I'd strongly recommend to find a partnership like that.
Very nice. So Bayreuth is gonna get some new friends probably from across the border, across the seas. All right. Then we have one more question from Joe, actually, from our side. He asks, given the wide variety of other autonomous competitions for students in the US, like DARPA or Mars rover competition, how did you sell Formula Student as the better one to your recruitees?
It's way better.
It's a tricky one, huh?
So one
It's
of the
definitely awesome.
Yeah, there are a lot of competitions right now that are not necessarily focused on full stack engineering. So not necessarily focused on the actual software hardware integration, which is what Formula Student allows you to focus on. There's a lot of other competitions out there that are kind of like, we give you this vehicle platform, you write software to run on it, and that's not what will make you successful, post academia. What really makes you successful post academia in the autonomous vehicle space is knowing the difficulties of writing a line of code and seeing that line of code blow up 12 times on a vehicle. And the Formula Student competition gives you the opportunity to do that. Whereas these other competitions don't necessarily stress that as much.
All right, thank you.
Well, there are a few more questions regarding sponsorship. So, and I guess some of them could be answered together. I mean, on the first hand, there's some, what's the best way to approach possible new sponsors? Other questions are related to the current COVID-19 restrictions, how COVID impacted your recruitment. On the one hand side, I guess, about team members, but also how it impacted to find new sponsors. Maybe you can speak a minute about that, sponsorship in general.
So COVID is tough. COVID's kind of, I don't know if anyone's listened to the news lately, but COVID's kind of screwing up a lot of things. And sponsorships is definitely one of them. So I can't paint a rosy picture for what's the best way to approach things in light of COVID. One thing I can say, though, is that certainly a lot of these, heavy tech companies are less affected by COVID. Which makes it, maybe there's a lot of other outside of the box sponsors that would be, harder to approach right now. But heavy, technically focused companies, especially software technically focused companies, are definitely less affected by COVID. So I would almost the strategy I would take with that is almost to think less outside the box in terms of COVID, because less outside the box is more focused on people inside the autonomy space, which are less affected. But then once things start settling down, I would definitely go against that and start reaching out to a broader spectrum of companies.
All right, cool. I think we're over time now, so thank you for answering all of your questions and all your interesting approach on how to recruit students. I mean, we definitely saw a lot of parallels to what we suggested in the first instance.